Hi, this is Mrs. Rodriguez with another lesson video. Today we're looking at proportional relationships with tables. If we're given a table with data, seeing if that table is proportional or not proportional, the relationship between X and Y. So let's get started. Now, before we begin with the tables, I do want to review what it means to be proportional. So remember, proportional means that there's a unit rate for X and Y, meaning there's a constant ratio between X and Y that does not change, okay? And because there's a constant ratio between X and Y, we know that Y is going to equal that unit rate, which we're going to call K, times X. And that unit rate will stay the same no matter what the X and the Y are, okay? K is the constant number that never changes for all X's and Y's. It's that constant number that you multiply X by to get Y. And we also have to remember that the origin is at 0, 0, meaning if X is 0, then Y is 0, or if Y is 0, then X needs to be 0. And if you think about it, it makes sense that the origin has to be 0, 0, that X and Y together have to be 0 and 0, the starting point. And it makes sense because if you work 0 hours, and let's say the hours is X, you're going to get paid 0 money, which would be your Y. If you don't work, you don't get paid. In the same token, if you pay $0, if your Y is 0, you'll get 0 pencils. And pencils is your X. So if you don't work, you don't get paid. And if you don't pay, you can't buy anything. So X and Y, the origin, the starting point for a proportional relationship, the origin needs to be at 0, 0. Okay, so another thing we don't want to forget is that X will always be the first, whether it's set of numbers, rows, columns of data, okay? So tables come in different forms. Sometimes they come in rows, sometimes they're made up of columns. So X will always be that first set of numbers or row or column of data. And Y will be the second set or row or column of data. So if we look at this table here, we can see that it's made up of 2 columns, and X is your first set of numbers, and Y, we'll make that pink, Y is your second set of numbers, okay? And if it is in row form, then X would be your set of numbers, the first set on top, and Y is going to be the second set of numbers, your second row on the bottom, okay? So if it's columns, X is column number 1, Y is column number 2. If it's rows, then X is going to be your first row and Y is going to be your second row. And a really easy way to remember that is to remember that X comes before Y in the alphabet. So if you sing the alphabet, it goes W, X, Y, and Z. Okay, so X and then Y. X comes first in the alphabet. So if you ever forget, okay, which one is X, which one's Y, remember that X comes first in the alphabet, so X will be the first set of numbers that you're working with, whether it's the first column or the first or top row. The other thing we want to remember is that K, our unit rate, equals Y divided by X. So if we're given a set of data, we can figure out what the unit rate is by dividing Y by X. So for example, in this first table, the mules and the hay, I'm right here, we can say, oh, okay, well, the unit rate is going to equal Y divided by X. So in this case, Y the first set of y's and x's, the first data points, would be 1 divided by 2, right? Because y is 1 and x is 2. And if I do 1 divided by 2, I get 0.5. So my unit rate is a half. And if I go through and divide all my y's by the x's, I should get a half for everything. So for the next one, it would be 2 divided by 4. That equals 1 over 2, which is a half. The next one is 3 divided by 6, which is 1 over 2, and once again, 0.5 or a half, and so on and so forth. Okay, so that means a half or 0.5 is our unit rate. So we definitely want to remember how to find the unit rate. Okay. All right, now let's look at whether or not a table is proportional. So a table is proportional if it has a unit rate that works for all of the x's and y's. So make sure if you find the unit rate for the first set of x and y, the first x and y, that's great, but you have to check all of them because maybe some of them work and it's only one that doesn't. All you need is one unit rate to not be the same in your data set to make it not proportional. It just takes one. It doesn't matter if all of them work but one. If there's one, then the whole thing is not proportional. And the other thing that you need in a table to make sure that it's proportional is that once again, the origin needs to be 0, 0. If x is 0, then y is 0. If y is 0, then x is 0. So let's take a look at two examples. The first example is proportional. Okay, so let's take a look. We know that in this example, it's 2 rows. So my first row is going to be my x, my second row is going to be my y. And if we'll remember, the unit rate is y divided by x. So for my first column, y is 5 and x is 1. So it's going to be 5 divided by 1, which equals 5. And now I'm going to do it for each one because I got to check and make sure that it works for all of them. So 10 divided by 2 is 5, 15 divided by 3 equals 5, 35 divided by 7 equals 5, and 50 divided by 10 equals 5. We get the same unit rate for all the data points, right? For each x and y. So that means, yes, it is proportional. Okay. There is no zero origin in here. It starts at 1, but that's okay. All the data points we checked, we got the same unit rate of 5, so this table, in fact, is proportional. And we automatically know that the origin would be 0, 0 anyways. And it makes sense because if x is time and y is water used, right? Maybe you're taking a shower and for every minute you use 5 gallons of water, and then 2 minutes it would be 2 gallons, 3 minutes it would be 15 gallons of water. Well, it makes sense that, I'll create another column. It makes sense that if you don't take a shower, you spend 0 minutes in the shower, you're gonna use 0 water, 0 gallons of water, okay? And if you don't use any water, you have 0 gallons of water you used, then you didn't take a shower. You have 0 minutes worth of taking a shower. So we can see that the origin for this table would be 0, 0 anyways. It's just not listed, okay? All right, now let's take a look at a table that is not proportional. So once again, we have x is the first row and y is the second row. And now we're looking at the number of tickets we bought and the total cost for the tickets. So we know that the unit rate equals y divided by x, and we can go through and divide each data point to make sure that we get the same unit rate. And if we do, it's proportional. If we don't, then it's not. Okay, so I'm going to start at the 2 and the 24. 24 divided by 2 equals 12. 28 divided by 4 equals 7. I don't even have to continue. Right off the bat, we divided y by x, and in the first one we got a 12, and in the second one we got a 7. So it doesn't matter if 32 divided by 6 or 36 divided by 8, those don't matter, because all you need is one that's not the same. And we can clearly see we have two different unit rates going here, so this is not proportional. Okay? Not the same, so it's not proportional. Okay? It's not the same unit rate, so not proportional. Another clue that this table was not proportional, the relationship between y and x was not proportional, is here, right here. Remember, the origin also has to be 0, 0. And the origin is not 0, 0, meaning if x is 0, y has to be 0, and if y is 0, x has to be 0. The origin is not 0, 0, so that's another reason why it's not proportional. I could have just looked at this table and said, what? X is 0, y is 20, bam, not proportional, just like that. I didn't even have to check the unit rates. And that's why I skipped the 0 and the 20, and I started off with the 2 and the 24, because I wanted to show you also what it would look like if the unit rates were different. So for this table, there's more than one thing going on that makes it not proportional. The first one is the origin is not 0, 0, and the second thing is we don't have the same unit rate for every single x and y. Okay, and the origin not being 0, 0, it makes sense why this would not be proportional, because for some reason they bought 0 tickets, but they paid $20, and that doesn't even make sense. A unit rate means it goes up at the same rate, at that same constant rate, right? It changes, or it goes up by the same amount each time. Well, so then that means if 2 tickets cost $24, that each ticket was $12, right? And if I had bought 4 tickets, I should have to pay $48. That wasn't the case. And also, if I buy 0 tickets, I shouldn't have to be paying anything. And that's why the origin has to be 0, 0, because it wouldn't make sense to have to pay $20 for nothing. So this is not proportional. All right? So let's take a look at a couple more examples. Here we have a number of mules and the bales of hay. Maybe this is how much hay they bought. And once again, we're just going to go through and check to see if it's the unit rates are the same and if the origins are good. So the first column is going to be your x, and the second column is going to be your y. And we know that the unit rate is y divided by x. So I'm just going to go through and do that. So for the first one, I have 1 divided by 2, and that's a half. And we already did this one. 2 divided by 4, that's a half. 3 divided by 6, that's a half. 4 divided by 8 equals a half. And then last but not least, we have 5 divided by 10, which is also a half. We have the same unit rate for all our data. For every x and every y, we have the same ratio. So that means, yes, oops, that means, yes, it's proportional. And it's okay that the origin is not listed, the 0, 0, because we know if there are 0 mules, then 0 bales of hay will get eaten. So it's a given that the origin would be 0, 0. Okay, let's take a look at a couple more examples. So for this one, we have x is 1, y is 4. Remember, we want to make sure we remember that k equals y divided by x. So we're going to check. There's no origin listed, so we're going to use y divided by x. And we have 4 divided by 1 equals 4. Okay. 40 divided by 10 equals 4. So far, so good. 25 divided by 5 equals 5. Oops. Nope, that's a problem. So it's not proportional. All right, let's check the next one. We have 5 divided by 1, which equals 5. 10 divided by 2, which equals 5. 15 divided by 3, which equals 5. And 20 divided by 4, which also equals 5. Okay, these are all the same, so it's good. It's proportional. All right, let's take a look at the next one. Bam! I don't even have to calculate any unit rates because the problem is right here. The origin is not at 0, 0. If x is 0, y should be 0, but it's not. Y is 1. So right off the bat, not proportional. Okay, so that's because origin is not 0, 0. So we don't even have to calculate anything else. Okay, and last but not least, which table does not represent a proportional relationship? Okay, so now we have to find one that doesn't work. So, for A, 3 divided by 3 equals 1. Okay. 5 divided by 6. It doesn't matter if you know what that equals. You know it doesn't equal 1, right? 6 divided by 6 would equal 1. 5 divided by 6 is not going to equal 1. In fact, it equals something like 0.833333, right? The 3 goes on forever. So, nope, not proportional. Let's check B. We have 2 divided by 3, which equals 0.6, and it goes on forever. 4 divided by 6, same thing. So far, so good. 6 divided by 9, same thing. So we're still good. 8 divided by 12, same number. And then we have 10 divided by 15. And we get the same thing. Perfect. So this is a yes, this is a no. All right, now it says which table. So A obviously is the table that doesn't work, but I want to show you that, let's say it was C or D. You have to go through and check all of them. We were just lucky in this case that the first table was the one that didn't work, but it's not always going to be the case. So you're going to have to go through and check each table to make sure that they are, which ones are proportional and which ones are not. C is pretty easy because you get 1 over 3, and 2 over 6 I know is 1 over 3, so that's going to be the same. 3 over 9 is going to be 1 over 3. 4 over 12 is going to be 1/3 as well. And 5 over 15, that also equals 1/3. So I can see that they all equal 1/3, so this is going to be a yes. And then for D, we have 4 divided by 3, which equals 1.33333, and then 8 divided by 6, which equals the same thing. 12 divided by 9, which equals the same thing. 16 divided by 12 also equals 1.3, and 20 divided by 15 also equals 1.3. So this is a yes as well. So as you can see, you go through, you check the unit rates for each set of x and y's, okay, each data point, to make sure that we have the same ratio or unit rate or constant of proportionality for every x and y, okay? And if they have the same unit rate, then they are proportional. And if they don't, like right here, if they don't, then they are not proportional. All right? So that's how you determine if in a table, the y has a proportional relationship to the x. That's how you can tell if your table is proportional or not, if y is proportional to x. Okay, and as always, if you have any questions or need additional assistance, please feel free to make an appointment with me for office hours. Hope you have a great day. Bye.